Hi, welcome to Responsive Cities. My name is Bige Tuncer. I'm an Associate Professor of Architecture and Sustainable Design at Singapore University of Technology and Design, SUTD in short, and I'm also a Principal Investigator at the Future Cities Laboratory, FCL in short. I'm trained as an architect. This is an introduction to my viewpoint on responsive cities. This viewpoint considers a responsive city as a smart city that places the users of cities at the center of technological developments and aims to bring the knowledge and opinions of users in a feedback loop where the future designs of cities is partially shaped by this input. My research group at SUTD, the Informed Design Group, focuses on this broad topic and delves deeper into various aspects of the topic. In this context, we ask ourselves, can we integrate big data, user preferences, and designer knowledge for urban design and planning support? This involves the development and deployment of tools for users and also designers of urban public spaces, sharing insights derived from this data. The data that's involved in these processes needs to be multi-source, multi-scale, and multi-time. Designers consider many different aspects of the artifact that they're designing simultaneously and frame and solve design problems using their professional domain knowledge as well as external information as it pertains to the problem and the context at hand. Therefore, when deriving insights from data, the variety and diversity of this data is an asset in the design process. In this context, we collect and use a combination of big and small data, both qualitative and quantitative data. We mainly focus on three categories of data. The first one is user behavior and opinion data, to understand how users utilize and also behave in urban public places using social media data, mobile phone data, sensor data, public data from various apps, observations, workshops, and interviews. The second one is data on the comfort of users of urban public places, be it thermal comfort, environmental comfort, visual comfort, etc. This is measured by using open and specifically collected data sets of climate and environmental parameters obtained by a variety of sensors, in addition to questionnaires and physiologically obtained data. The third and final data category is urban analysis and mapping of functions and physical characteristics of spaces. This involves conducting spatial analysis and mapping and examining the typologies and attributes of urban public spaces, such as urban furniture and greenery. The obtained data is then analyzed, integrated, and visualized. We use multi-dimension and multi-measure analysis techniques to derive evidence from the collection of data and relate various spatial aspects of places to various behavioral aspects of users. We develop computational models where we can examine various place characteristics in combination with the behavior of various groups of users over time. We create online platforms for the public and designers to query the data and insights derived from this data, built upon the analysis techniques and the computational models. We then formulate and codify the derived evidence within parametric design tools in order to integrate insights derived from actual users into the design of new urban public places. We call this evidence-informed urban design and planning processes. I will now very briefly mention three exemplary projects that apply this methodology. In Art in Places, together with Ludovica Tomarchio, we mapped the spaces in Singapore where art is produced, discussed, and broadcasted to an audience using social media data in order to derive insights about how the as-planned spaces performed in their actual use and to discover emerging art spaces in Singapore. In Running and the City, together with Özgün Balaban, we mapped the urban leisure running behavior of city dwellers using open app data and related this with other data sets of climate, crime, demographic data, and street typologies. The end goal is to improve urban streets in order to enhance the urban running experience. In Tropical Covered Walkways, Together with Ramanathan Subramanian, we collect data from existing covered walkways in order to model the thermal comfort of its users and use machine learning to create a tool that ranks various design alternatives by thermal comfort of users. This work is inherently interdisciplinary. We work with software engineers, electronics engineers, data scientists, architects specialized in participatory design, sociologists, cognitive psychologists, among others. Within FCL, we collaborate with many groups in order to bring data into design in a meaningful way. To conclude, users of cities is the backbone of the concept of responsive cities, and evidence-informed urban design and planning processes play an important part in achieving responsive cities. Thank you.